Hello, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Zeno. That special channel created for you and I to come together to demystify mathematics and tackle the age-long phobia often associated with this important subject, one topic at a time. Thanks so much for staying tuned, staying subscribed, and please don't forget to like, share, and always tune on your button so you'll be the first to know when our subsequent videos are released. Today, we are looking at another aspect of the topic algebraic fractions, which we have treated in the past, in previous videos. In the very last video, we looked at the operation of addition and subtraction of algebraic fractions. Today, we are looking at something different entirely, and that is substitution in algebraic fractions. You know very well that when you say substitution in mathematics, it simply means you are replacing a letter with a numerical value, and or at times another letter entirely, just like in the round leather game of soccer. When you say substitute, it means you are replacing a player with another player, usually in the same position. However, in mathematical soccer here, we are substituting by changing a letter with a number or another letter entirely. So let's see how this pans out when it comes to algebraic fractions. Now, the question comes if x over y equals 4 over 5. Evaluate 3x plus 4y over 2x minus 3y. Okay, this is a good example. However, I must say that this particular opening statement can also be written as x ratio y equals 4 ratio 5. That's another way of writing the opening statement. It's pretty much the same. Now I'm going to show you formally what I call the lazy man approach of solving this question and the appropriate approach really. To start with, the lazy man approach is on the assumption or presumption that x is 4 and y is 5. That is not necessarily true. Because what if x had been 8 and y was actually 10? Remember, 8 over 10 simplifies to 4 over 5. So we cannot simply then say that x is actually 4, y is 5. That's why it's dangerous to use that approach. Nevertheless, we still go ahead and see how it works out. So if we assume that x is 4 and y is 5, it simply means we are saying that what 3 times 4 plus 4 times 5 over 2 times 4, minus 3 times 5. Assuming that x is 4 and y is 5. So in that case, we're having 12 plus 20, that is 32, over 8 minus 15, that is minus 7. And that gives us minus 4 over 7. Is that straightforward? But again, asterisk is dangerous because there are some certain questions that these assumptions will fail. So it's better not to take the risk by gambling your mark away in an exam. So what I expect to do, you actually go the whole of and do the needful, mathematically speaking. So since we have x over y, we are going to express everything in terms of x over y as much as possible. And the way to go is divide each term here by y. So I'm going to have 3x over y plus 4 y over y over 2 x over y minus 3 y over y. So I'm dividing each term by y. And that results in 3x over y plus 4. So that gives us just 3x over y plus 4 over 1 over 2 x over y minus 3 over 1. So we can now then literally lift this x over y, which is 4 over 5, into this position. That's 4 over 5 plus 4 over 1 over 2, 4 over 5 minus 3 over 1. So So you can then multiply that to give us 12 over 5 plus 4 over 1 divided by, that's the numerator, then 8 over 5 minus 3 over 1. Now, let me quickly say this. A common mistake that candidates make is to use this same 3 to multiply this 5. That is very wrong. Because this 3 is in numerator, it's actually 3 over 1. So it's 3 times 4, 1 times 5. So it's not 3 times 4, 3 times 5. It's not. It doesn't work that way. It's not like expansion. You're not expanding there. So this results in 12 over 5 plus 4 over 1. The SN is clearly 5. That is 12 plus 20 divided by, likewise here, SN is 5. That's 8 minus 15. And that results in 32 over 5 divided by minus 7 over 5. Which is pretty much the same answer we got earlier, minus 5 over 7. So the answer eventually becomes minus 32 over 7, or minus 4 over 7. Now, the question might be, why go through all this process? Why would have done the direct substitution? Remember, that is quite risky. It's like a trial and error. In some cases, it will fail. And since you never can tell which case that method will fail, it's best you stick to a method that will always work in all situations. So that is how to solve the problem of substituting in algebraic fractions. Now let's take another good example. This time around, the example is going to be a reverse process, meaning you're going to be given something like this, you are asked to get the value of x over y. So let's see how that plays out. So the question goes like this. Given that 2x plus 3y over 3x minus y equals 3 over 11. Find correct. So 2 decimal places, a value of x over y. Fantastic. This time around, we are actually asked to look for the original value x over y. That will give us this. However, to 2 decimal places. So all you need to do is to just simplify that algebraic fraction there, equation as it were. So here, when you cross multiply, you have 11 bracket 2x plus 3y equals 3 bracket 3x minus y. Open brackets, you have 22x plus 33y equals 9x minus 3y. So correctly like terms, I have 22x minus 9x equals minus 3y minus 33y. I'm having the x on one side and the y on the other. So this is going to be 13x equals minus 36y. So since I'm required to get x over y, that means I must have division by y. So divide both sides by y, I'm left with 13x over y equals minus 36y divided by y. That becomes 1, of course. Like I said, I already have my x over y, so I have to get rid of this 13. Like similarly, dividing both sides by 13. So that gives us x over y equals minus 36 over 13. That is the answer already. Except for the fact that we are told to correct our answer to 2dp. That means we must compute this. And in doing that, we're going to have x over y being minus 2.76923. But because of the instruction that we must leave it to this degree of accuracy, don't forget that, that will be approximately minus 2.77. And that exactly is how that also plays out. I believe you found this quite interesting and fun, as I expect. If you do, please don't forget to do the usual, which is to subscribe, like, share, and tune in your button so you'll be the first to know when the next video shall be uploaded. And that will be again substitution in algebraic fractions. This time around, we are substituting letters, not numerical values. Thanks and stay blessed.